Hey, what's up, guys? So for the online learning day, that's going to happen on Wednesday, just after the weekend break. Um, I would recommend that you do this worksheet and another one that we're going to be doing in preparation for Chapter 6 that we'll be covering in the next unit. In Chapter 6, we're going to be learning about rational functions, or functions that are expressed as ratios or fractions, pretty much. And so we'll be dealing with operations like multiplication, division, subtraction, addition, but as it relates to fractions. So we should be very familiar with how to multiply, divide, add, and subtract fractions. Um, so we'll practice with numbers, and when we get into chapter 6, we'll practice with polynomial functions. So for this first question here, let's just go through some of these expressions, and then I hope that you guys go through and do them yourself. But so here we're multiplying two fractions. Now multiplying fractions is pretty simple. Unlike adding and subtracting, you don't need a common base. Or a common denominator, sorry, you can just multiply straight across. So I can multiply this 1 and this 5, and this 2 and the 4. So for me, I'll just write this as 1 times by 5 divided by 2 times by 4. It's equal to 5 over 8. And that's really as difficult as it needs to be, really. There might be times where you have to reduce the fraction that you end up with, and we can do examples of what that might look like. But in any case, that's pretty much it. So let's say that we go down and hey, this would be a good one for number 13. See, we multiply the 14 over 9 times by the 7 over 10. Now, one thing that you can do is just the same deal. We can multiply straight across. We can do the 14 times by 7 divided by the 9 times by 10. And we can add those together, right? Or we can multiply those together. So whenever we do that, 14 times by 7. Let me pull up my calculator here. 14 times 7, we get 98 over 9 times by 10, and that ends up with 90. Now, that is a fraction that can still be reduced. So here, when it says find the value of each expression in the lowest terms right there, that means we just want the fraction to be as simplified as possible. So we know that both of these are divisible by 2, so if we reduce them by a factor of 2, we get 98 divided by 2 would be 49. 90 divided by 2 would be 45. And I think that's as low as that can be reduced. Now, so we did this by multiplying straight across and then simplifying here, but we could even do this an alternative way. So remember that we ended up with 49 over 45, but let me show you an alternative way if you can see common factors. So here, let's do it again. We multiply the 4 and the 7, 9 and the 10, so we get 14 times by 7 over 9 times by 10. Now, here, if I recognize the fact that 14 has a factor of 2 and 10 has a factor of 2, 7 and 9 don't have any common factors because they're prime. So any common factors besides 1. But 14 is the same thing as 7 times by 2. So here, if I rewrite 14 as 7 times by 2, and then I divide this by 9 times by 5 times by 2, I recognize that 10 can be written as with a factor of 2. Now, if you ever divide, like here we have a 2 and a 2, well, these are factors that can cancel out. So those cancel. Factors on top and bottom, common factors on numerator and denominator end up canceling. And so, because 2 divided by 2 is 1, so it's relevant. Okay. And then here we'll be left with 7 times by 7 over 9 times by 5. 7 times by 7 is 49. 9 times by 5 is 45. And there you go. You get the same thing. Now, the reason why for me personally, I prefer doing this is because whenever I do 14 times by 7, I had 98 over 90. I don't really like reducing fractions. I don't find that quite as easy as it is here, mainly because these are larger numbers, so it's harder to maybe see what common factors that they might have. But with lower numbers like 10 and 14, if you reduce these factors like we did here earlier on, it's easier than reducing the factors like over here whenever we would reduce this to this. So in any case, so the earlier you can reduce the fractions, in my opinion, the better. Okay? So keep that in mind as you work on those type of problems, as you work on these problems. Okay, now that's multiplying fractions. Let's talk about dividing fractions right here. So when we have 1 over 6 divided by 8 over 11, another way here of visualizing this, if you did 1 over 6 divided by 8 divided by 11. So we'll see expressions like this in chapter 6. It's another way of writing it. But it's a very confusing expression. 1/6 divided by 8 over 11 can be very confusing. But essentially, if you have a fraction divided by a fraction, well, it's actually the same thing as multiplying by its reciprocal. And a reciprocal is just whenever you flip the top and the bottom. Okay? So here, there's a rule that I like to use. It's kind of just like a thing to help you remember how to divide fractions. It's called the keep, change, and flip rule. This is how I learned how to divide fractions. It's a pretty simple process, but you have two fractions, 1 and 2, right? And you have them being divided. So the keep, change, flip rule basically just states that you keep the first fraction as it is, so 1 over 6. You change the sign from division to multiplication, and you flip the second, so 11 over 8. This is the reciprocal of 8 over 11. And this is equivalent to this right here. So 1/6 divided by 8 over 11 is the same thing as 1/6 times by 11 over 8. They are the same expression. And so now, if you convert this expression into a multiplication expression, now you can multiply, which is what we just learned how to do. So multiply straight across. So 1 times 11 is 11. 6 times 8 is going to be 6 times 8 is going to be equal to 48, yep. Okay, and there you go. Found the expression right there. Okay, let's try a couple more. So for something like 7, if we use the keep, change, flip rule, keep the first, 11 over 2, change the sign, and flip the second, 2 over 1. Okay, now instead of multiplying 11 by 2 and 2 by 1, which will give me 22 over 2, which would just give me 11, I'm just going to cancel out these factors here. So because multiplication doesn't really matter, you can multiply straight across, you get 11 times 2 over 2 times by 1, and you can see that either way we have it, the 2's would cancel, so we're just going to be left with 11 right there. Okay? So that right there is how to divide fractions. So we know how to multiply, we know how to divide, so go through this worksheet, complete these examples. I have a key in Canvas, so make sure you compare your work there, and I think by doing this you'll be really prepared for what comes in Chapter 6.